Hello everyone, I'm Wenjing from the Research Assistance Center at the University of Alabama. In this semester, I'm going to create several videos to show you how to do data exploration and visualization using R. In today's video, I will cover these 4 topics. First, I will briefly introduce data visualization, then I will show you how to obtain and install R and RStudio. Then I will introduce some data structures in R, and finally we will see how to read and export data in R. Data visualization can help us explore and understand our data. We can use data visualization to present and explain results of our study. Data visualization can also help us attract and engage readers. To do data visualization, we need some tools. In this semester, we will use R or RStudio. Why do we use R? R is a free software environment for statistical computing and graphics. R has many flexible and powerful packages. And also, R can be installed on Windows, Mac, and Linux. So no matter which operating system you are using, you can always install R in your computer. Now let's see how to install R and RStudio. To install R, we need to go to this website, so please click this link. It navigates us to our website. And you can see here we have 3 options: download R for Linux, download R for Mac, and download R for Windows. I will show you how to download R for Windows. So please click download R for Windows. And we have 4 subdirectories. We choose the first one, base. And you can see download R 4.0.3 for Windows. I think this is the latest version for R, so we click it. And you can see here's an installation script. When it finishes, we can double click it. We click OK, then next. Because I have installed R in my computer, so I just click yes, and click next. It may take some time. Okay, we click finish. Okay, let's go back to our slides. To install RStudio, we need to go to this website. So please click this link. It navigates us to RStudio website. If you scroll down, you can see RStudio desktop. It's free, so we click downloads. And to install RStudio, first we need to install R that we just did. So we can go to the second step directly, download RStudio desktop. We click this button here. And here is another installation script. Okay, we double click it. We click next, install. Oh, by the way, RStudio is an integrated development environment for R. It is more user-friendly, so we will mainly use RStudio. Okay, we click finish. Now let's go back to our slides. When you open your RStudio, you can see this general layout. There are 4 panels. The upper left panel is a text editor. Here you can type any R commands, and also you can save them as a file. The lower left panel is an R console. Here you are going to see our R commands and corresponding outputs. The upper right panel shows information of our current workspace and commands history. The lower right panel displays any plots we just create and the packages information and help files. Now let's move on to the data structures. In R, we have these 5 data structures: vector, matrix, data frame, list, and array. We will mainly focus on the first 4 data structures because they are commonly used in our field. A vector is a collection of elements. Each element in a vector should be the same type. A vector has a length, which is equal to the number of elements. In R, we have 3 vector types: numeric vector, logical vector, and character vector. A numeric vector is a vector of numbers. A logic vector is a vector of true and false. A character vector is a vector of strings. Now let's see how to create vectors in R. Typically, we can use C parentheses to create the basic vectors in R. For example, if we would like to create a vector which consists of 4 elements, 1, 2, 3, 4, we can use this R command, C parentheses 1, 2, 3, 4 parentheses. And then we can use assignment operator to assign the vector we just created to an R object X. If you type X in R, R will return this vector we just created. Now let's go to RStudio to see how to type the R command. As we mentioned before, in the text editor, we can type R command. If we would like to run this command, we have 2 ways. First, we can highlight it and then click Run. In your R console, you can see this R command. Alternatively, we can use our keyboards. We can press Ctrl and Enter at the same time. And in R console, you can see this R command. If you want to print X, you can type X here and Ctrl Enter. In the R console, you can see this vector we just created, 1, 2, 3, 4. Okay, let's go back to our slides. Another way to create a vector 1, 2, 3, 4, we can use 1 column 4 here. And if you type Y in R, R will return this vector we just created. Similarly, we can use C parentheses to create a logical vector and a character vector. R has 2 specific functions that we can use to create vectors. The first function is seq function. We can use this function to generate sequences incremented by a specified constant. For example, if we want to create a vector which contains 5 even numbers, 2, 4, 6, 8, and 10, we can use this R command. The first input of the seq function is the starting value of the sequence. The second input of the seq function is the maximal end value of the sequence. Because the increment is 2, we specify by is equal to 2. Sometimes we would like to create a sequence with a specific length. For example, we would like to create a vector with a length of 5. We can use this R commands. The first and the second input of the seq function are still the starting value and the end value of the sequence. The difference is here. Instead of using by arguments, we specify length is equal to 5. The other commonly used function to create a vector in R is rep function. Rep function allows us to replicate a value several times. The first input of rep function is the value we would like to repeat. The second input is the number of times to repeat. For example, by using this R command, we repeat 5 3 times. And we can use assignment operator to assign this vector to an R object X. If you type X in R, R will return 5, 5, 5. Sometimes we may want to create a vector several times. We can still use rep function. Instead of putting a single value in the first input, we can put a vector in the first input. For example, we want to repeat a vector 1, 2, 3, 4, 5 twice, we can use this R command, and R will give this output. Sometimes we may want to repeat each element of a vector several times. For example, we want to repeat 1 twice, 2 twice, 3 twice, 4 twice, and 5 twice. We can use this R command, and you can see the R output. Sometimes we may want to repeat each element of a vector different times. We can still use REP function. For example, we may want to repeat 1 once, 2 twice, 3 times. We can use this R command, and when you type A in the in RStudio, I will give you this output. So in summary, for REP function, the first input is the values we would like to repeat. The second input is the number of times to repeat. Now let's see vectorized computations. I collect some common operations for numerical vectors. For example, vectors A has 4 elements, 1, 2, 3, 4. For each element of vector A, we can calculate its square, reciprocal, logarithm, and square root. We can also use the sum function to calculate the sum of the elements. And also we can use the mean function to calculate the mean. Now let's go to the RStudio to see these operations. We already have the vector, but I use a different vector name x, so we just use x. First, we will calculate the square of each element of vector x. Control Enter, and in R console you can see this is the square of each element in vector x, and we can use 1 over x to calculate the reciprocal, and we can, what else we have, logarithm x and the square root x. You can see all the outputs shown in R console. And we can use the sum function to calculate the sum of the elements in vector x. The total is 10. We can use mean function to calculate the mean. That's 2.5. Okay, let's go back to our slides. R has some comparison operators, such as less than, greater than, equal to, not equal to, less than or equal to, greater than or equal to. For example, vector A has 4 elements, 1, 2, 3, 4. We would like to check whether each element in the vector A is less than 3. We can use this R command, and R return this output. True means the element is less than 3. False means the element is greater than 3 or equal to 3. If we would like to know how many elements that are less than 3, we can use this R command. R treats true as 1 and false as 0, so there are 2 elements in vector A that are less than 3. R has some logical expressions. We can use ampersand and double vertical lines to represent logical and logical or respectively. We can use an exclamation point to represent logical negation. We can use parentheses to link expressions. For example, x is equal to 3.5, y is equal to minus 5.7. We want to check whether x is less than 5 and y is greater than -3, we can use this R command and R return false. Or if we would like to check whether x is less than 5 or y is greater than -3, we can use this R command and R returns true. Now let's see how to access the vector elements. We can use square brackets to extract vector elements. This is the vector x. It's a sequence from -5 to 4. The increment is 1. If we would like to extract the second element of the vector x, we can use x square bracket to square bracket. Now let's go to RStudio to see how to type this R command. If you double click x and then use Ctrl and Enter at the same time, in the R console we can see this vector x from -5 to 4, and we would like to extract the second element of the vector. We use this R command, and you can see in R console it's a -4. It's from here, the second element of vector x. Now let's go back to our slides. If we would like to extract the first 3 elements of vector x, we can use this R code and R return this output. If we would like to extract the first, third, and fifth elements of vector x, we can use this R command and R return this output. Sometimes we would like to extract everything in vector x except the first, third, and fifth elements. We can use this R command. The only difference between this R command and the previous one is the minus here tells R we don't need the first, third, and fifth elements. Okay, let's move on to matrices. A matrix is a rectangular with rows and columns. Every single element in a matrix must be the same type. We can use the matrix function to create a matrix. The first input of matrix function is a number in the matrix. The n row here specifies the number of rows in the matrix. N col here specifies the number of columns in the matrix. By row here specify how we put the numbers in the matrix. We put the number by row, so we specify by row is equal to true. And then we can use assignment operator to assign this matrix to an R object A. By running this R command, we can get the matrix A. It's a 3 by 2 matrix. Now let's see how to access elements, rows, and columns in a matrix. To access an element as the mth row and nth column of matrix A, we can use A square brackets m, n square brackets. This is the matrix A here. If we would like to extract an element at the first row and the second column, we can use this R command and R return 2. 2 is from here, the first row, second column. Sometimes we need to extract the entire mth row of matrix A. We can use this A square bracket m, square bracket. For example, we would like to extract the first row of matrix A. We can use this R command and R return 1, 2 here. It's the first row of matrix A. Similarly, if we would like to extract the entire nth column of matrix A, we can use A square bracket, n square bracket. For example, if we would like to extract the second column of matrix A, we can use this R command, and R returns this output. This is the second column of matrix A here. We can also extract more than one rows or columns at the same time. For example, if we would like to extract the first two rows and the first two columns, we can use this R command, and R return this output. It's the first two rows and the first two columns. Now let's see a real dataset, air quality. It is an R built-in dataset. It contains 153 rows and 6 columns. Now let's go back to RStudio to see this dataset. If you type air quality here and Control Enter in R console, you can see this dataset. But sometimes we just would like to see the first 6 observations of the dataset. In this case, we can use the head function to get some basic idea of the datasets. And Control Enter, you can see R just print the 6 observations of the dataset, and this dataset has column names and row names. To get the dimensionality of the dataset, we can use dim function. Air quality, this is the dataset that we are working on. And the 153 here tells us we have 153 observations. 6 means we have 6 variables. Now if we would like to extract a temp column, we have 2 ways. First way is what we did before. We use air quality square brackets, comma 4, and we can Control Enter. R print the temp column here. Alternatively, we can use air quality square brackets, comma temp, and we hit Control Enter. R gives the same results as this R command. By the way, R is case sensitive, so the T here should be capital T because in the dataset it's capital. Now let's go back to our slides. I have shown you this in RStudio, so we move on to the next slides. We can use the subset function to select some records which would meet certain conditions. For example, we want to select the records whose temperature is higher than 80 Fahrenheit. We can use the subset function. The first input of the function is a dataset that we are working with. The second input is the condition. So we use the head function again to just print the first 6 observations that meet this condition. What if we would like to know which months have temp greater than 80 Fahrenheit? We can still use the subset function. Apart from the dataset and the condition here, we use select arguments. In our example, we let select be equal to months because we would like to select the months variable. And here is our output. The next data structure that we would like to introduce is data frames. A data frame is a rectangular with rows and columns. Each row represents one observation and each column represents a variable. Within a column, elements must be the same type, but between columns, elements can be different types. So data frames are more flexible than matrices, because a matrix requires all elements to be the same type. Now let's see how to create a data frame. For example, we would like to create a data frame named diamond, which contains 4 observations and 3 variables. To create this data frame, we first need to create variables in the data frame. In our example, they are price, carrot, and cut. These three variables are three vectors. As we learned before, we can use C parentheses to create vectors. After we create these three variables here, we can use data.frame function to create a data frame in R. Then we use assignment operator to assign this data frame to an R object, diamonds. If you type diamonds in R, R will return these data frames that we just created. Now let's see how to obtain the basic structure of the data frame. We use diamonds as an example. If we would like to know how many rows in diamonds, we can use nRow function here. The input of the function is the dataset we are working with. In our case, it's diamond. R return 4. That is, there are 4 rows in diamonds. Similarly, we can use uncall here to obtain the number of columns in diamonds. R return 3. That means we have 3 columns or 3 variables. We can also use dim function to obtain the dimensionality of this data frame. Sometimes we would like to obtain the column names and the row names of the datasets. We can use call names function and row names function respectively. We have learned how to access elements, rows, and columns of a matrix. For data frames, it is the same. If we would like to extract an element as the mth row and nth column of a data frame A, we can use A square bracket m comma n square bracket. For example, we would like to extract the elements as the first row and second column of diamonds. We can use this R command and R return 0.7 from here. To extract the entire mth row of a data frame A, we can use A square bracket m comma square bracket. For example, we would like to extract the first row of diamonds. We can use this R command and R return this output. It's from here. To extract the entire nth column of a data frame A, we have 2 ways. First, we can use A square bracket comma n square brackets. For example, we want to extract the second column of diamonds. We can use this R commands. Alternatively, we can use dollar operator. For example, we want to extract variable carrots. We can use this R command. Diamonds is the dataset name, dollar, then we type carrots. It's the variable name. The dollar operator can also be used to create a new column. For example, we want to create a new column named color in diamonds. We can use this R command. By typing diamonds in R, R return this new dataset, which includes the color variable. In the matrix section, we learned we can use subset function to select some records which meet certain conditions. The subset function can also apply to data frame. For example, we want to select some records whose color is E. We can use subset function. The first input of subset function is the name of the dataset. The second input is the condition. So by running this command, we can select records whose color is equal to E. The last data structure that I would like to introduce in this video is a list. Lists can contain different types of elements, such as numbers, strings, vectors, matrices, data frames, and lists. We can use the list function to create a list. For example, we would like to create a list named list_data. We can use list function here. The first element of the list is a vector. The second element is a matrix. When you type list_data in R will return the list that we just created. We can also give names to each element in the list. To do that, we can use this R command. When you type list_data again, R will return this list. This time, it has the name for each element in the list. To extract the elements of a list, we have two ways. First, we can use double square brackets. For example, we can use this R command to extract the first element of the list_data. Similarly, we can use this R command to extract the second element of the list. The second way is to use dollar operator. For example, we can use this R command to extract the second element of the list. A matrix here is the name of the second element of the list. The last part of this video is to show how to read data from an external CSV file and how to export data to an external CSV file. First, let's see how to read data from CSV file. We can use read.csv function. For example, we would like to read a CSV file named tips to R. We can use this command. In the quotation mark, we put the location of the CSV file and the name of the CSV file. If we use head function, R will return 6 observations of the dataset. Similarly, to export data from R to an external CSV file, we can use write.csv function. For example, we want to export the tips data to an external CSV file named tips_new. We can use this R command. The first input is the name of the dataset in R. In the quotation mark, we put the location of the CSV file and the name of the CSV file. Okay, that's all for today's video. Thank you.